When we imagine a planet, we naturally look down at our own feet. We see stable ground, deep blue oceans, and a protective layer of white clouds. This local perspective creates a massive built-in bias for what a world is supposed to look like. Even when we look outward toward our lifeless cosmic neighbors, we still assume a baseline level of structural normalcy. We anticipate a sphere of rock, perhaps a thin atmosphere, and a relatively quiet surface. This made the discovery of exoplanet HD 189733b deeply reassuring. From a distance, it looks like a beautiful deep blue marble, suggesting a twin to Earth. Silicate, the same material used to make glass, creates that blue atmosphere. In the extreme heat, it melts into liquid droplets that violent winds whip across the sky at 5,400 miles per hour. This world experiences storms where molten glass rains down completely sideways. Scientists recently used the James Webb Space Telescope to analyze this world further and detected hydrogen sulfide in the clouds. This means the 1,700-degree planet of glass storms also reeks of rotten eggs. The stability of our own system is a cosmic exception. To grasp the reality of the broader universe, we must look at the violent physical forces responsible for engineering its most disturbing worlds. Gravity is the first architect of chaos. While we think of it as a force of stability, extreme gravitational environments weaponize a planet's own mass against it. Consider Gliese 876d. This rocky world is larger than Earth, but trapped in a disastrous orbital position. It exists in a perpetual tug-of-war. Its own sun pulls it tightly forward, while giant gas planets in the same system constantly yank it backward. This constant stretching and squishing keeps the planet's interior completely melted. The result is a world of non-stop massive earthquakes and a surface that is constantly flooded by boiling magma. This gravitational torture escalates even further when a planet gets too close to its sun, leading to a state called tidal locking. The gas giant WASP-12b serves as the most extreme example. WASP-12b orbits its star in just over 1 Earth day. Being that close allows the star's extreme gravity to physically stretch the massive gas sphere into a deformed rugby ball shape. Measurements from the Hubble Space Telescope show that the star is actively stripping away billions of tons of gas every second. The planet is literally being eaten alive as it spirals inward toward total destruction. In the deep universe, an orbit is rarely a safe harbor. It is frequently a slow, agonizing execution. Beyond physical pulling, planets must survive thermal and radioactive bombardment. While we associate stars with life, they often act as violent sterilizers. Proxima Centauri b is our closest exoplanet neighbor, sitting just over 4 light-years away in a theoretical habitable zone where liquid water could exist. Its red dwarf star erupts almost daily with stellar flares. These explosions are hundreds of times more powerful than anything produced by our sun. Billions of years of this X-ray and ultraviolet bombardment have taken their toll. Any surface oceans have likely boiled away, and the planet's entire atmosphere has been violently stripped off. While radiation strips Proxima Centauri b, the super-Earth 55 Cancri e suffers from outright thermal melting. It orbits so close to its star that a full year passes in less than 18 hours. On the day side, temperatures reach 4,000 degrees Fahrenheit, creating a global ocean of boiling liquid rock. The heat is so extreme that the melted rock evaporates into the sky. When winds blow these rock vapors to the cooler night side, they condense and rain down as solid stone. Stellar energy operates as a brutal, sanitizing force, easily overriding a rocky planet's capacity to maintain a stable environment. The final architect of chaos is the catastrophic failure of orbits themselves, leading to massive kinetic collisions and planetary ejections. TOI 1853b, known as the Iron Bullet, is a Neptune-sized world that survived a hyperspeed impact with another giant object. The violence of that crash splashed off the water, the rocky surface, and the gas layers into space. What remains is a hyperdense core of heavy metal with crushing gravity. Kinetic destruction is one path to ruin. Another is extreme cosmic isolation. HD 106906b is a gas giant located impossibly far from its twin suns. It formed much closer to its stars, but their intense gravity eventually acted like a slingshot. The planet was violently kicked outward into the freezing, dark edges of the system, where a single orbit takes 15,000 years. Planets remain at the mercy of chaotic celestial mechanics, easily pulverized into raw metal or exiled into the freezing void of deep space. To finalize this tour of horrors, we must look at the absolute coldest extreme, the planet Ogle 2005 BLG 390p. Temperatures here drop to -364 degrees Fahrenheit. At this level of cold, chemistry as we know it completely stops. If this world ever possessed an atmosphere, the cold would have caused the air itself to freeze solid. The gases would have fallen to the ground as a layer of permanent snow, leaving the surface in absolute pitch-black silence. Seeing worlds where glass rains sideways and atmospheres freeze solid recontextualizes our place in the universe. Earth exists as a massive statistical anomaly, a fragile, impossibly lucky sanctuary in a universe seemingly engineered for absolute destruction.